9.1. So we're going to talk about correlation and causation. Okay, just because two variables are strongly correlated does not in itself imply some cause and effect relationship. Okay? So the example I use here to demonstrate this point is the variable representing the number of snake bites per month versus another variable, the number of snow cones sold per month. Okay? What if I told you that these two variables here were related? They had some correlation of R of like 0.95. What does this mean? This is a strong positive correlation. Okay? So that means as the number of snake bites increases, the number of snow cones sold increase. Therefore, Congress passes a bill saying no more snow cones are allowed. We got to get these snake bites down. Now, this is silly, but this is how people misuse statistics all the time. They say, look, there's a high correlation between the two variables. Therefore, it has to be this cause and effect relationship. Okay? So you need to be very careful. All right? It doesn't necessarily mean that there isn't a cause and effect relationship. That's not what I'm saying. I'm just saying that it doesn't imply that there is one. All right? So when somebody uses statistics and they say this happened, therefore this is happening because these are highly correlated, you can automatically say you're misusing correlation. There is no cause and effect relationship with correlation. Okay, so causation versus correlation are two different things. All right, so there might be some other relationship going on between the two variables, okay, that causes some correlation, some third element. And if you've thought of it already, great. And if not, well, that third element could be the temperature. The hotter it is outside, the more snow cones you sell. The hotter it is outside, the more likely snakes are be out of hibernation and they're slithering around biting people. Okay. So when there is significant correlation between two variables, a researcher should consider the following. Is there a direct cause and effect? Relationship. Okay, like X causes Y. All right, so this would be a direct cause and effect. So like maybe the relationship between GDP, gross domestic product, and carbon dioxide, CO2 emissions. As the economy grows, there are more factories producing more and more CO2 emission. So it would make sense that your CO2 emissions increase as the GDP increases, a cause and effect relationship. Is there an inverse cause and effect? Okay, relationship going on here. Well, Y causing X to happen, right? So like an example that might be Old Faithful, the relationship between how long the eruption lasts and then the time before the next eruption. So the duration may affect the time, or the time may affect the duration. All right. Now the third one, this is what we were talking about earlier, Is it possible that the relationship between the variables is caused by some third variable or combination with the snake bites and the snow cones? The third variable could be the average temperature for the month. Okay? So warm weather produces more snakes and more snow cone cells. And then the last question the researcher has to ask themselves if they see a significant correlation: is it possible that the relationship between variables might just be a coincidence? So like an example, if I had like the number of animal species living in a certain area versus number of families with 3 or more TVs. Okay? Neither one of those have anything likely that's related. Okay? So some correlation between the two might just be a coincidence. So those are the questions you have to ask yourself as a researcher if you find some significant correlation here. All right, guys, hope this helps explain causation versus correlation.